All right, gang, taking off from where we ended off the previous video. All right, we'll go on to problem number 4. So find the probability of an event from the previous problem. What is the probability of an event A? Now, you probably just watched it. And remember, an event A is just that the sum is 10 or higher. So we can define the probability as being the cardinality of A over the cardinality of S. Now, cardinality, what is that? That's a big fancy term. It's really not. Cardinality just means the count in the set. So just up here, let's just jump up here and say we've got some set Q that consists of the numbers 1, 7, and 11. So the cardinality of Q would be 3 because there are 3 numbers in the set. All right, so our set A, as we defined it from before, was the sum is 10 or higher. Their cardinality would be 1, 2, 3, 4, 5, 6 because it occurred 6 times. And the cardinality of the sample size would be 1, 2, 3, 4. Yeah, you got it. 6 by 6 would be 36. Now, you can do whatever floats your boat here. Probability can be given as a fraction, or we clearly could just write that as 6 over 36 in our calculator and round it to, whatever. 0.167, thereabout. All right, part B. A stats class has 50 students, 22 are female, the rest are male. What is the probability a student is selected at random and they are male? Well, the same thing here. Probability would be the cardinality. So we're doing what? That they are male over the cardinality of the entire sample space. Well, there are 50 students in the entire sample, and there are 22 female, the rest, so it looks like to me the probability of being selected at random, they being male, would be 28 out of 52. This could also be written as 0.56. The only thing I don't like to see is probability written as a percentage, even though it's an equivalent statement to say that 56% of the students are male. It doesn't ask for a percentage, it asks for a probability. So probabilities are between 0 and 1. Always, let's repeat that, it's extremely important. Probability is between 0 and 1. If your friend, your buddy, whatever tells you they got a probability of 1.2, then they're wrong. It can't be. It has to be between 0 and 1. Probability of 0 tells you it's not going to happen. Probability of 1 tells you it's going to happen every single time. So expressed as a decimal or as a fraction. Now, another thing we get into is the use of tree diagrams. And these things can get really, really messy. The one that I just assign you in my stat lab is not messy. The one I'm going to do here is exactly like it, also not messy. All right, so a tree diagram works like this. It creates your sample space by looking at things that happen over sequences. So a fair coin is flipped twice. So that's the sequence. We have what happens the first flip, and then we have identify what the options are for the second flip. So on the first flip, if it's a fair coin, then it has to be either a head or a tail, right? The second flip, we could get either a head or a tail. And if it was a tail, we could still get a head or a tail. So if we follow this so-called tree, we could see that one option is to get a head and a head. Another option is to get a head and a tail. Another option is to get a tail and a head. And another option is to get a tail and a tail. So this would be the sample space created by a tree diagram. All right, now you can see what if we were flipping this 3 times. Well, from this H we would go HT, and from this T we would go HT, and so on and so forth for the others. So you would the very first thing you would have would be HHH, and then you would have HHT. So you would have three outcomes because you flipped the coin 3 times, right? So what is the probability of rolling 2 heads? Well, when we go to our sample space, we can see that, again, the probability of the event is the the cardinality of the event, which I'll just have E here, and the cardinality of the entire sample space. Well, the event here is what? Rolling 2 heads. It only happened once. How many elements do we have? What's the cardinality of our S? 1, 2, 3, 4. So the probability of rolling 2 heads would be 1/4. The final thing we get into in preparing you to do the probability lesson in STAT1800 is permutations and combinations. Now, a permutation is a situation of statistics where we want to look at the possible options, outcomes, where order is important. So let's say we're sitting around a table and we're interested in defining a particular order. Carol sits here, and Bill sits there, and John sits there, and whatever sits there. A combination doesn't worry about order. It just wants to look at all the possible outcomes irregardless of order. So here, order is important. And for this, order is not important. Now, the formula for the permutation, and I'll just do this in standard form in PX, okay, is, if I can remember this, n factorial over n minus x factorial. So it kind of bounces off the factorial concept that we learned early in the previous video. So in this case, since, is that a 6? It's so small I can't see it. Yeah. So the n would be 6, and in this case our x would be equal to 3. So here I'm going to have 6 factorial over 6 minus 3, 3 factorial. Now that'd be easy to put in our calculator. Again, just doing what we did before. So again, we want 6, and don't do anything goofy and like do that 2 fact. No, that's just completely wrong. Just go ahead and work out the problem. So we want 6 factorial divided by 3 factorial. So we're going to get what? 120. So there would be 120 options of taking 6 objects, arranging them 3 at a time, where order is important. Now, you might have seen when I was doing all this that there was a key that you thought might apply. It's called NPR, right? They use n's and r's. I use n's and x's, right? But same thing. So what I could do here is I can quit that and notice that to put the 6p3 I would do this, and guess what we're going to get? 120. Now, the next is a combination. So the formula for, and I'll use n's and x's just as I did before. is n factorial. Really, it's almost exactly like the permutation, except there's this x factorial in the denominator. So what we would do here is we'd have n factorial, which in this problem would be 5. My next door neighbor is mowing his yard or weed eating, and it's extremely annoying. Then x factorial, 2 factorial, and then we would have n minus x, which would be 5 minus 2, which would be 3 factorial. Now you got to be kind of careful when you put this in your calculator because you have to make sure that this is all contained in the denominator. So I'll show you how to do that. So we'll go 5 factorial. And then we're going to divide by, and I'm going to go left parentheses, 2 factorial. Times 3 factorial. In parentheses, so that forces that 2 factorial and 3 factorial to be in the denominator. We find the product of it, which we need. Now these are always going to be larger. Well, it's different numbers, so it's not going to be larger, but so the answer here would be equal to 10. Because order's not important, so we kind of have some free range. Now, you may have noticed again that we had a combination option in our calculator. So if we're going to replicate this problem, which is 5, and then we can go to the combination function in your calculator. So that was like 5, choose 2, and you'll see we get 10 again. So super cool stuff. If you use the formula, or if you use the feature in your calculator, it works out the same. There's actually a way you can also do these in StatCrunch. I'm not going to demonstrate that now because I demonstrate it later in the videos where I teach. But I will tell you, if you just are interested in that, there's so much information out there. If you'll just kind of be aggressive and take the initiative, just go into some browser, into Google, for example, and just type in permutations and combinations using StatCrunch. And you're going to be surprised how many videos will pop up where you can learn from another resource. All right, guys, that's all I got. Now, no, it's not all I have. I want to show you what is really going on here. Now, when you go to Assignment Manager and you go to assignment number 2, and let me go to actually what you would see. So when you go to Assignments, and you go to assignment number 2, and you start the questions, let's take a look at the first 10 questions. Factorial. Look familiar? Yeah, because I just taught it to you. Counting? Look familiar? Yes, I just taught it to you. License plate? Look familiar? Yep, just taught it to you. Familiar? Yep. Probability, statistics class, numbers have been changed, look familiar? Absolutely. Tree diagram, look familiar? Yep, I just taught it to you. Permutation, combination, sorry for the redundancy, look familiar? Yep, I just taught it to you. All right. Now, I want to ask you, if I had taught you all this stuff a semester ago, 2 semesters ago, a year ago, 2 years ago, 3 years ago, would you be prepared to use it now in STAT1800? Or do you think it's more effective to use an hour of the class to review, charge you additional hour for this class, but not require you to take 3 hours for Math 102? All right, I'm getting on my soapbox here, but I think this is going to be a lot more effective. All right, gang, take care.